Hello, everyone. Welcome to the June 2026 Indicator of Behavior meeting. I'm the IOB chair and your host, Charles Frick from Johns Hopkins Applied Physics Lab. Really glad to have everyone here today. Uh, just wanted to give you a brief bit of news on what we're working on the IOB project, and then kind of go into our technical talk. I'm very happy to say that we get to share the results from the operational pilot that we concluded at the end of 2025. All of that release authorities have been approved and looking forward to sharing that with you guys. But first of all, for some general news on IOB, we are still actively conducting research. I'm not sure if a revision 5 will be pushed out later this year or not. Uh, we've had a couple bits of feedback. Really, the only suggestion that I think they'll be making it in right now is the idea of adding an additional relationship between indicator behavior detector objects and the behaviors that those detectors are relevant to. Currently, detectors have a relationship to detection analytics, and detection analytics have a relationship to behaviors, but there's been some feedback that a detector behavior relationship could be beneficial for a few different use cases. So we're looking into adding that, as well as some general small edits and cleanup on some data within a few of the objects, mostly revisiting some of the MITRE ATT&CK references that we have associated with behaviors. And some of our researchers have made some good arguments that there might be a couple more applicable sub-techniques to link up. So we're going through that and making sure that that's all working correctly. Aside from that, as always, we're eagerly monitoring the community Slack and the listserv for questions and ideas that people have for IOB. And in our own research that we're conducting at the laboratory, we are putting together some prototypes for the use of AI agents and MCP servers to better utilize IOB in a SOC and quasi threat hunt type environment where we could basically establish a repository of known behaviors and push various SIEM alerts to an AI agent that can help guide somebody through understanding, do certain alerts align with known behaviors? And if they do, help identify related behaviors and correlations that might be relevant for them to verify. So that work's coming along nicely. It's pretty exciting. I'm hoping that we might have something releasable by our September meeting in the fall. But that's a quick update on where we're going with that. And for really the majority of today of this quarter's call, I wanted to share with you guys a talk that I recently gave at a conference. So allow me to get my screen share going and move some of my Zoom windows around so that I can see all of you while I'm and any questions in the chat that might rise up. So I will just get these organized real quick and take you through what's going on. So just as a little bit of background, in 2025, we worked quite hard to establish an operational pilot of using indicators of behavior in production defense workflows. We partnered with the Hudson Alpha Institute for Biotechnology in Huntsville, Alabama, who were willing to install some IOB analytics and automation in their environment and let it run for a few months, and we could collect some data. And I'm looking forward to sharing that with you. I presented all of this in May at the IEEE CyberBio workshop on cyber biosecurity, with Hudson Alpha being a innovator in the biotech field. This was a good opportunity to utilize a cyber biosecurity conference to share how this new research could apply in those parts of critical infrastructure. Hence the title, Operational Validation of Behavior-Based Cyber Detection in a Live Biotechnology SOC. all these slides are TLP clear. And I believe, Kurt, I'll put you on the spot for a second, but I believe these also just went live as a PDF on the IOB GitHub if anybody wants a copy of the slides.
Yes, just merged it.
Thank you so much, Kurt. All right. So some of this may be a little bit old hat uh, for people that have been following IOB for a while, but just kind of level setting, we've been seeing for years security operations flooded with alerts, and that not necessarily helping us find attacks sooner. And as we've said many times on these calls, indicators of compromise have their value, but they're static, easily changed, and are identified after the damage is done. And that even utilizing sticks and attack, we're not getting enough specificity to take action. So kind of that big bumper sticker. Traditionally we've been collecting signals, but struggling to translate that into meaningful detection and action, at least in a time that can prevent cyber attack. And that is what we've been working on trying to address in IOB for all this time, that we needed a standard way to share the detection logics, the correlation strategies, and also response workflows. And so I won't belabor this point because I know we've talked about these amongst ourselves several times over these calls, but that led to the motivation for creating IOB. I think a few of you have probably seen this slide from me before. I was just describing the fact that we really needed something midway between an indicator of compromise and the attack framework that could be more operational, which led to our need for indicators of behavior. And just kind of update this to provide people new to the topic some background, a tiny bit of background on sticks rather than go heavily into that right now. But essentially what we've been saying for a while, that with IOBs, we could identify, for lack of a better word, dumber analytics that have more false positives, but that are meant for a machine to look at. And when analytics are correlated, that's when we would notify an operator. And we've been saying this for some time, and we've shown quite a few experiments from our own integration environment, but we thought it'd be really important to actually do this at some place that wasn't Johns Hopkins Applied Physics Lab and show it working for real in somebody's environment. And that's where the Hudson Alpha Institute for Biotechnology comes in. So it's a fairly large campus, and they do a lot of cutting edge genomics research with focus in medicine, pharmacology, and agriculture. But what also makes them a very unique partner for a pilot is they're an innovation hub. And what that means is they host 40 different biotech companies. And so they provide laboratory space, office space, but most important for our research, they're also the internet service provider for all these startups. So they have network access and they control the perimeter to the internet for 40 different biotech companies. And they provide the security of that interface. So when it comes to being able to observe network activity and potential threats, this is a really nice place to be where we can see various patterns of communications from different types of companies, different enterprises. They also have a good educational outreach, which makes them very friendly to conducting this type of research. So they are a fantastic partner. Can't say enough good things about them, and very grateful for their participation in letting us install IOB in their production SOC. With that said, let me tell you a little bit more about what we actually did. So for the overall design of the pilot, this started off in early 2025. Hudson Alpha provided us information on their architecture, their sources of various logs, their SIEM, the SOAR and automation engines they had access to, threat intel platforms they were utilizing, as well as their policies for their firewalls and proxies and endpoint detection, so that we could better understand all the data sources that were available to them. And we recreated that infrastructure, as we've done in previous pilots, in our integration environment here at the lab. So we have the same version of the detection technologies, we also were setting up our Ghost, utilizing the Ghost framework from Carnegie Mellon for emulating user activity on those networks. And we integrated the same SIEM that they were using and got all the log collection together. And as we did that, that allowed us to go build IOB bundles. We did a couple use cases of threat emulation that I'll talk about in just a moment. And we translated that into the right behavior-based analytics for SIEMs. We identified the behaviors, tested everything, and we packaged up a full IOB set of IOB bundles for Hudson Alpha to make use of in their production. After we did that, we then delivered those down to Hudson Alpha in Alabama and worked with their SOC to get that installed in production so that this could be running in the background and we could start collecting data. And then after several months, Hudson Alpha provided us the feedback on what was useful in the IOB structure, as well as metric performance, so we could actually show how this worked in production. We really designed IOBs around two separate threat cases. First one is a lot of the genomic data has great monetary value. These are very gene sequencing, and the research being conducted has extremely valuable insights that are gained and used in various industries. Bio is growing at an alarming rate. And so one thing that we were concerned about is how well are we able to detect when data is leaving the environment? And so we looked at a scenario about what if an attacker were able to gain access into one of the tenant companies. And when I say tenant, I'm not talking like a cloud tenant, but one of those 40 hosted biotech startups. If one of those machines is compromised and credentials get stolen with attackers utilizing creating rogue VPN access, these are all things that we've seen in living off the land attacks, that they might enumerate a network utilizing things like PowerView and taking cracked credentials to laterally move to some of these genomics workstations that are connected directly to the gene sequencers. And essentially, for this case, establishing a rogue S3 bucket to dump the data. And I mentioned a rogue S3 bucket because these organizations are constantly setting up infrastructure out in the cloud to hold this data because DNA data is quite large. And so the information writing to an S3 bucket by itself is not all that uncommon. Information writing to a brand new S3 bucket is not all that uncommon either. So this can actually become quite difficult to detect because if valid creds are being used and somebody's not being very loud and using valid credentials to remotely access machines, a lot of this type of traffic looks legitimate, even if it is, in this case, an attacker stealing that type of data. So that was one use case we're really curious about. This is the main one that we installed in production. Hudson Alpha also, with a big education mission, actually has a cyber biosecurity test environment and test range, and they allowed us to put up a second, a little bit more malicious attack on that test range and collect data as well. For this one, it starts very similar, gaining access onto a single workstation and installing a covert VPN. But then we utilized ARP and Nmap scans to map out a network. And when we identified a particular machine that was hosting genomic data, we then uploaded malicious PowerShell scripts to cause integrity compromises of that data, essentially shuffling up the A, C, T's, and G's in the DNA sequences. And we did that because that's actually quite tricky to verify and check right now if it happens at the source, because the main data integrity check is checksums. And so if one were to modify the source data, modify the checksums, and essentially rewrite some of the metadata over to be the same creation and modified dates as the source, that's not super hard to do, but that would be that would most likely get around most integrity validation, but you could poison some very valuable data. So you could see how these two ideas might work hand in hand if somebody was really looking at a type of um, espionage or corporate espionage scenario of wanting to steal valuable data while poisoning the source so that they could steal from the originator without and making it look like the original data itself was garbage. So this was another use case that we were interested in seeing if we could represent with the IOB bundles. And we provided all of that down to the folks in Alabama, and they let it run for about 3 months. And I want to show you guys some of the findings. To start with, this next chart I'm about to show you is going to be a little bit of an eye strain. But essentially, this is the number of alerts happening every day during the data collection period. A blue line is an individual behavior. These are stacked bar charts, actually. The blue portions are individual behaviors that are looked at by automation and never notifying an operator. This is when just a single behavior fires. And if you see an orange bar, means that a pair of behaviors fired. And in this case, we did not notify operators. But if all three of a set of behaviors fire, then we notify an operator. And that, is kind of highlighted in that tiny little sliver on that one spike on that one day. So, and I'll talk more about what caused that red bar and that red part of the bar in just a second. But this is what we've been saying all along, that the analytics can be noisier if automation is looking at that, because even though these are thousands of alerts on some days, it's not thousands of notifications. Only when a correlated set of behaviors is observed is an operator notified, because we share the correlation logic and we implement that correlation logic via automation. So all this lives inside the JSON for this pilot, which also, by the way, these artifacts, the IOB bundles, they're also available on our GitHub. They've been publicly released along with the analytics and the correlation workflows. All of that's available on the reference implementation portion of the indicator behavior GitHub repository. But essentially, as I was saying, we want automation to look at the different behaviors and say, did a computer potentially map the network with abnormally large LDAP responses? If so, was that same computer establishing new remote sessions across the network to hosts that it had not connected to before? And if so, again, did that remote session start sending data to an S3 bucket that we've never seen before? When all three of those occur and are related, then we want to notify an operator that there might be something to look at. And so a better way to think about that for this data theft use case, this is a kind of a summary, is that over roughly 3 months, we had about 8,241 times that a single behavior was observed. They don't indicate a threat by themselves, and an operator was never notified. About 645 times, a pair of behaviors were correlated. And with the logic that we agreed upon with Hudson Alpha, this also does not indicate a threat and does not notify an operator. But 2 times, a set of 3 correlated behaviors was observed that represented a true threat. And in fact, both those times were during a threat emulation exercise that we conducted with Hudson Alpha to go through this use case of stealing data, where we stole some fake data and moved it to a rogue S3 bucket that we set up. And not only were the only 2 times that we got a high correlation true positives, we were able to notify operators within 5 minutes of the correlated activity being observed. And so I think this in itself is quite powerful and very useful. Additionally, we did similar threat emulations in their test range, but since it was a test range, we were able to do a few more events. And so for the data integrity compromise, we saw over 137,000 individual behaviors firing with no operator notified. about 650 times a pair being observed. And in the test range, we had 21 times that a correlated set was detected, and all 21 were due to threat emulation runs that we had done over the 3 months. Now, on this slide, I have a slight note saying operators would be notified. The timing is still the same, that the polling for new correlations was occurring every 5 minutes. That could be adjusted based on your automation environment. Our agreement with Hudson Alpha was to run the correlations every 5 minutes. And we did not generate SOC operator notifications off the test range because they asked us not to, saying that the test range alerts don't go to their SOC. They would go to someone playing a blue team in the test range. So out of respecting their wishes, we recorded when the notification would be sent, but for this use case, we didn't provide the notification because we didn't want to be a distraction. Overall, I'd say this is pretty promising results, and it's really great to get that out there finally. So essentially what we learned is kind of what we've been saying, that these behavior-based detections do work in operations, that you can do it in a vendor-agnostic standardized format, and correlation is the key. And that you can get high-fidelity alerts emerging from a coordinated sequence of adversary behavior. And these open machine-readable formats made it possible for us to make these type of analytics portable across different infrastructures, different tooling and environments, and provide real operational benefit to find some fairly advanced attacks without needing to rely on any indicators of compromise or proprietary analytic. So this was a really big win for us and our team. Got to prove this live with rapid detection under 5 minutes, which is much faster than the industry average to detect adversary activity, and validated those detections with minimal operational disruption. And then some links, of course, to the project and to GitHub to get access to all of our data. But I just wanted to share that with everybody for a moment, because I think this was a pretty big success for the IOB concept, and ask if we had any questions, comments, or concerns over what I just went over. And I think, Vasilios, you have a question.
Yes, thank you for the presentation, Charlie. Very interesting, and also to see that the work is progressing, right? And we have some testing in, let's say, in more realistic environments. So my question is, if we try this to really, right, if we try to incorporate this in a, let's say, real operational environment, right?
Mhm.
How this would look like. Now I'm thinking that, on one hand, right, we will have like a CM solution and other systems and components. On the other hand, we have the IOB bundles, right, that basically describe different behaviors in Sigma. And if I'm not mistaken, right, we encode let's say the operators, right, with relationship. What happens first, what happens second, so we can create this branching. How this is transposed, into a real environment? I mean, is it only the CM, and we would need to come up, I'm trying to say, right, with some not complex detection engineering, but with a solution that would provide us with this, let's say, granularity, considering that possibly we have, single alerts, but somehow we need to couple them, right? And then we will be able to say, okay, we have more or of higher priority alerts compared to the standalone ones. How this would look like, and does this capability actually exist considering real operational environments and existing solutions?
So for this pilot, we were able to do that with a SOAR. We actually used the Sorka SOAR for this particular pilot, so that we could design some of the playbooks in Cacao and execute them. That said, this was also during the time that we were making some adjustments to the Cacao standard when it came to like a data bus. So for full transparency, we did have some fairly customized Python in some of the execution blocks on the workflow to handle some of the correlation. But the idea is going to be, one route is an automation automation engine to help translate and analyze those analytics coming out of the SIEM. I think there's also an opportunity to look at how some of these could be integrated into EDRs and NDRs to help do some of that correlation as well. I think there's a few different options, and that's I think part of the power of having it in a standardized format, that we could integrate this into various types of technology for like different environments. But the way that we've been deploying right now is very much a SIEM SOAR combination for a lot of enterprise.
So if I interpret it correctly, let's say that we have like for now, I'll call them singular detections at the SIEM side, but then you perform the correlation at the SOAR side. Yeah. And then how do you feed these things back? I mean, okay, possibly you issued, as you said, some kind of notifications or whatever, but I saw the slide that was saying, the operator was not notified, right? But the operator has access to this SIEM itself.
Yes.
And there it will start getting a little, let's say, crazy with the additions of, because right now, maybe in the past you would make a decision, I should not have, let's say, detection engineering that could possibly generate many false positives. But now you require it, right, for correlation reasons, right? Because the simple one will go to something, more important, let's say, and you need this type of correlation. So how can we handle this?
Oh, yeah. Sorry. Thank you for asking, as I left that out. So in the production SIEM, these alerts essentially went to an index that was marked for automation. And so that was a quick bit of operator training saying, hey, they were informed that there will be some noisier analytics that are intended for automation under this index. That's not one that for you to work into your day-to-day investigation. Now, that doesn't stop a curious analyst from choosing to stare at all that, but it keeps it from entering their normal workflow. And when we had a correlated set, we used their case management, to notify their operators. That's the workflow that they use.
Yeah, that's excellent, right? And that's the reason I like this group, because simple like decision making like this, right? But now I'm saying, oh, it makes sense, right? I mean, it's not something complex, but still, knowledge sharing, right?
Yeah.
Indeed, I haven't thought about it. How am I going to handle this? So thank you for answering this.
Oh, sure. And I should say another reason we didn't notify the operator from the test environment that I left off when I was going through that narrative, there actually is a whole separate SIEM in the test range, so that those alerts from the test range don't get mistaken for actual threat activity on the live network. So we had integrated actually across two different instances of a SIEM.
And then last question from my side. I mean, I saw your use case, right? And I saw that you had like a detection on, I'm not sure if it was like accessing an S3 bucket or exfiltrating data to an S3 bucket, but this takes me back to what's the sweet spot, in this, let's say, detection logic on informing an operator, because maybe, the S3 bucket, let's say accessibility, right, or action goes closer to the actions on objectives. So maybe we need to have some kind of, sweet spot that could give, an earlier notification, right? So how do we decide about these sweet spots? And yeah,
and this was also going back and forth with things that their security team were most interested in. So I agree that you would like this use case to be detected prior to data being written out, because but at the time, one of the things we looked at was that it's really hard, like when attackers want to steal data this large, sending it off to S3 buckets is one of the most effective techniques to do, because every day this network observes petabytes of data going to S3 buckets. So that in itself can't generate an alert because it's happening all day long. But being able to tell, is this S3 bucket that might have just been created an hour ago is that legitimately made by one of our host companies, or did some random person just create that? That becomes very, very difficult to make sense out of in itself, which is why writing of data S3 buckets would be an analytic that nobody would ever do at Hudson Alpha normally, because it happens all day long. But that's when we can, but if we feed that to that automation index, we can start gathering information and seeing if the machine sending that data is associated with any other recent behaviors. And then that becomes potentially malicious. So otherwise, it would be completely benign. Yeah.
Now this takes us back that maybe we cannot generalize extremely, right? Because we need to achieve a very good level of, let's say, fidelity, right? So we will need to understand organizational context and, day-to-day operations to achieve this supreme, let's say, detection engineering.
I think that I think there's still a sweet spot of being able to detect. Like, I don't think this is going to be so tailored that it has to be strictly Amazon S3 buckets following this exact pattern of activity. I think we could eventually generalize this type of detection for large data writes out, and then look at a few different combinations. Because you could also see if it's associated to more than just, say, using LDAP to map the network, though that tends to be one of the more effective routes, because a lot of tools have built in things to find things like Nmap scans. But I do agree, like, there's still some work to be done as we look at how to build a larger master repository of behaviors to share across different communities. But still gives me a lot of hope.
And out of curiosity, and that's possibly a naive question because I haven't checked your bundles right now, but how many of the, like in the threat narrative, right, you created detection engineering, let's say, how many of them are non-tool dependent, such as like Mimikatz and, installs,
So none. None. So we detect, it depends on, I would call SSH tool independent. Anything could be called that. So that was based off network protocol. We were using DNS analysis for the writing to the S3 buckets. And and actually this one was, I think, almost all network analysis. And then we were looking at the size of LDAP responses to hosts to identify. So that could have been done. We did that with Cobalt Strike. You could do that with Sliver, any C2 frame, or your own C2 framework, anything that you'd want, because essentially it was just using legitimate credentials. Now, I will say in our threat emulation, we did use Mimikatz to crack the local credentials, but that wasn't one of the analytics that we were using. If you had an analytic for finding something like that, that would definitely fire. But we thought it'd be more interesting to say, let's just even assume something like a initial access broker provided credentials that somebody bought off the dark web. And so your attacker just started with a valid set of creds to use. We wanted to see what we could find out from that. And I see a lot of, like I said, I definitely saw, and I could be biased here, but I really thought the LDAP network enumeration was quite a useful analytic, because once you can look comparatively across like any type of baseline of LDAP communications, while machines talk to the domain controller all day long, they very rarely print out a list of all the hosts and IP addresses. And so the byte size is orders of magnitude larger than any normal communication for just about any environment. And I think that's a really handy thing that we should just be doing in general more often, looking for. I haven't found a real legitimate case for that yet. But anyhow, but that's the answer to your question about the analytics.
Thank you.
Absolutely. Are there any other questions about the pilot data? I always take silence as concurrence. In that case, I will stop sharing and open the floor real quick to any general questions or comments that folks might have. Always happy to share with you guys as much as I know about what's going on with the project and where we're trying to take things next. If anybody has any questions, not to put anyone on the spot. Well, in that case, as always, folks, I'm grateful for your time and your help. I'll have a summary of these notes and the YouTube recording of that presentation available for everybody, hopefully by the end of this week. And just grateful for your interest and participation, and just letting you know that we're still taking this and moving it forward slowly but surely each day. So with that, thank you guys, and I will see you again in September.
Thank you all. Bye bye.
Thanks, everybody.
Thank you very much. Bye bye.
Good to see y'all. Bye.